Hello students, today I have come up with one more problem in electrodynamics for you students who aspire to appear in the IIT exams, or the series of problems that I discuss here online. There may be problems which are of good standard, high standard. There may be problems which are medium standard. There may be problems which seem to be easy, but we have to do everything. So you have to bear up with me. We do a spectrum of problems on electrodynamics. We start from easy to moderate to good level to the extreme level. So you should be learning all sorts of problems. Here I have come up with one more problem, that is, it's a frame, a closed circuit, and in this closed circuit it is a slider in between, and the slider moves to the left, and the magnetic field passes through this wire frame. When you push this slider to the left with velocity v, what happens? The flux on this side decreases and the flux on this side increases. So when the flux changes, there is induced EMF. When the flux through this part of the circuit or this part of the circuit changes, there is induced EMF in the wire. When there is induced EMF in the wire, the circuit is closed, it will send current through the wire. Some current will go this way, some will this way, and the current flows through the circuit, and that current also flows through the wire itself. And when the current flows through the wire, it's the slider itself. Now this is a slider carrying current in the magnetic field. So there will be a force on this slider. The force is on the right side, because now the motion is to the left, force has to be on the right side. Force is opposite, always opposite. The magnetic force always opposite the motion of the slider. So how to find the net? How to find the total force on the slider, which is on the right side? How to find it? That is our question. The force on the slider. What is the force on the slider? What is the force on the slider? On the slider, which moves to the left with constant velocity v. That's the question. So first of all, I have to find what is the potential difference between the ends of the slider, induced EMF, by moving the slider to the left. The flux changes here, so you can find it out, or you already know it is VBL. Or we can do it again here. Suppose this is from here to here, it is x. And when the slider goes to the left, this x changes, x decreases. It decreases at the rate of v. When the slider goes to the left, x changes. This change in x with respect to time is simply the velocity. So what is flux? What is flux here? That flux is B magnetic field into this area, Lx. Differentiating both sides, d phi by dt, that is equal to BL dx by dt. It is induced EMF A, that is BLV. You are already knowing this, the induced EMF. But which side is positive and which side is negative? Which end will become positive? Which end will become negative? When the slider goes to the left, this flux, whose direction is inwards, this flux will decrease. The current will be in such a way as to increase that flux. When you get the slider to the left, the flux in this part of the circuit will decrease. The current will be such as to increase that flux. So current has to have this direction, so that this current, let me suppose I1, this current will produce its own field inwards, because inward flux is decreasing by pushing the slider to the left. That's how we find the direction of the current. Current is in such a way as to oppose the change. the flux is inwards, the slider goes to the left, the flux inside tends to decrease, so this current will tend to increase that flux, or will try to keep that flux constant. The current should be such, so current has to be anti-clockwise. There is one more rule, if you want to remember that. I will show you the rule. If this flux, if induced EMF is positive, then anti-clockwise current. That is all. But for that, we have to find how induced EMF will be positive. If it is negative, then clockwise current. But you have to remember only one thing. If induced EMF is positive, then current is anti-clockwise. So here induced EMF should be positive. How? Let's see how it will be positive. But for that, you have to remember certain things. D by dt is change in flux. If it is taken as positive, if there is increase in flux. Now, flux itself should be taken as positive if it is inwards. Flux should be taken as positive if it is outwards. तो इन तीन चीजों से ये निकल सकता है कि देखो, पहली बात है कि if the change d by dt is just the change, if this change is increase, take it as positive. If flux is outwards, take it positive. But if flux is inwards, then it has to be taken negative. If the change is decreasing, then it is taken to be negative. Under these conditions, under these known facts, if E is positive, then the current is anti-clockwise. Let me find it out again. I will again find it out. So that you remember when the current is clockwise or when it is anti-clockwise. See here. Induced EMF is minus d by dt. Okay, let me suppose phi here. Induced EMF minus of the formula. What is d by dt here? Does flux increase or decrease? Flux is inverse. When you cut this slider to the left with velocity v, what will happen to the flux inside? That will decrease. So take it negative, because increase in flux is taken as positive. Is flux inwards or outwards? Flux is again inwards. Outward flux is taken as positive. What about inward flux? Inward flux. So when the flux is inward, you get the slider to the left, the flux decrease, so it is taken as negative. And now the flux is inwards, therefore it should again be taken as negative, because outward flux is taken as positive. Three negatives will make negative. So here induced EMF is negative. So should the current be anti-clockwise or clockwise? According to this rule, it should be clockwise. That's why current is clockwise. This is clockwise current. And here the current is anti-clockwise, because the reverse happens. When the slider goes to this side, the flux here increases. The only thing happens, the flux increases, so this part will become positive, and therefore the current will be anti-clockwise, because two negatives will make positive. This will be positive. In this case, when the slider goes to the left, this one, in this part, the flux increases, therefore this is taken positive. So negative to negative is positive. So in that case, current is anti-clockwise. So current is like this: I2. So these two currents go downwards through the wire. So this end becomes positive, this end becomes negative. So it sends current like this, and it sends current like this. It becomes a battery type. The current comes out of the positive terminal of the battery. So if you already know current is this and this, you must know it is positive and this is negative. And how much current flows through this wire now? I1 plus I2. Okay? How much current flows through this wire? I1 plus I2. I1 from here, I2 from here. Okay. Now, what is the induced EMF? The induced EMF is the slider going to the left, there is an induced EMF, this becomes positive, this becomes negative, sends current like this, it sends also current like this. It is, these two resistors are in parallels. So I1 flows through this part and I2 flows through this part, and both the currents flow downwards through the wire. And when the two currents flow down through the wire, now the wire carrying current I1 and I2, the wire carrying current I1 and I2 is now in the magnetic field, which is inwards. It will experience force in the backward direction. So it is wire like this, magnetic field inwards, magnetic field inwards. So I cross B, the force is in this direction. It is I, current is like this, downwards, magnetic field is inwards, and force is this way, right? Okay, I have to find how much is the force. First of all, let me find what is the induced EMF. That is V, B, and L, right? What is I1 current? That is potential difference, this induced EMF, divided by this resistance. So that is V, B, L by R1. What is I2? Current through this part of the resistor. Again, potential difference by resistance R2. I2 is equal to V, B, L by R2. Now, how much is the current flowing through this slider, which slides to the left with constant velocity V? So I is equal to I1 plus I2. That is VBL by R1 plus VBL by R2. Now what is I? That's equal to VBL 1 by R1 plus 1 by R2. That is current passing through the slider. This much of current is passing from top to bottom, downwards. Okay, now this current carrying conductor is now in the magnetic field. How much is the force? How much is the force? How much is the force now? How much is the force? So F is equal to I L cross B. Now it is I, L and B. Why? Because the angle between L and B is 90. It is L, right? And it is B, inwards. L and B, angle is 90. So it is ILB sine 90, that is ILB. So how much is the force? How much is the force? The force is F equal to, yes, what is I? That is VBL 1 by R1 plus 1 by R2. That is I. What is L? That is L again. What is B? That is B. Now what is force on this slider in the back direction to keep the velocity of it constant? If the velocity is 0, the force will cease. The force will become 0. But so far as the velocity is constant, you have to create backward force to keep the velocity constant. The backward force is a magnetic force. To keep this velocity constant, you have to push it in the forward direction with the same amount of force. I want to clear the statement. You see, when you keep the velocity constant of this slider, there is a backward force, that is magnetic force. Right? For that, to keep this velocity constant, you have to push it forward with the same amount of force. So if you don't push it forward with the amount of force, the velocity will decrease and become 0 because of this force. So keep the velocity constant. To keep the velocity constant, you have also to push it in the forward direction, in this direction, in this direction with the applied force. So that applied force will keep the velocity constant. If you don't apply force, this magnetic force will make the velocity 0. Okay? So F is equal to VB square L square 1 by R1 plus 1 by R2. That is the answer. So in the question R1 and R2 was given, L was given. So you need to substitute all the values of R1, R2 and L and V. If these values are given, you can find the magnetic force on the current carrying conductor. This much of force you have to create in the forward direction to keep the velocity of the slider constant. This was one of the problems that may benefit you for those students who want to appear in IIT or some other exams. Thank you. But don't forget to watch my lectures on the YouTube and continue to watch my lectures, and also download my app, Tantray Sir Physics Classes. Thank you.